Determine the relationship between 1 and 2 below. Okay? So we have an integral from 0 to the power of 4 of sine squared of x cosine of x dx. Okay? And so if we want to solve that explicitly, we do a u substitution where u equals sine of x. And then we have this one right here, which is the same, but it doesn't have cosine of x. And so with the second one, we could solve that, but we'd have to use a half angle formula. It'd be kind of a fundamentally different method of attack. But what they're asking here is just which one is bigger than the other one. So it's like, all right, is 1 bigger than 2, 2 bigger than 1? Do they equal 0? Do they both not equal 0 but are equal? Okay, so let's look at, so this is from 0 to pi over 4. So sine of 0 equals 0. Sine of pi over 4, and I know that looks like a 9, it's a 4. That looks like a y now. Square root of 2 over 2, which is about 0.7, about 0.707. And so 0.7, the important part is it's less than 1. So it probably looks something kind of like this, and then there's probably like an inflection point or something. So this is kind of sort of what sine of x will look like. Okay? Now the other one, 1, is modified by cosine of x. And cosine of x, so cosine of 0 will be 1. Cosine of pi over 4 will be square root of 2 over 2 as well. So we get something kind of like, maybe like this, where it starts at 1 and then goes lower. And so what's going to happen here is we're looking for area under the curve. So it's going to be multiplying this by cosine of x. And that multiplying is always going to be multiplying by something less than 1. Well, except for cosine of 0. Cosine of 0 at one single point will be 1. But after you're at that single point of x equals 0, you're going to be multiplying by a value that's less than 1. So what's going to happen then, if you look at this as simply just area under the curve, if you graph these out, what's going to happen is this cosine of x is going to make the sine squared of x graph smaller, lower, closer to 0, because you're multiplying by a value less than 1. So if you multiply by something by 1/2, it's going to be smaller than the original. And that's what's happened here. Not by 1/2, by some value that's between 1 and 0.7. And so when you have this graph here that you're making smaller and smaller and smaller, then the area under that curve is going to be smaller and smaller as well. I know you really won't have time to graph this when you're taking an AP exam, and you definitely won't have access to Wolfram Alpha. But let's take a look, see what it would look like. So we have sine squared of x cosine of x for 0 less than x less than pi over 4. You get something like, like this. And then if we put on there as well sine squared of x, we can see here that sine squared of x cosine of x is less than sine squared of x. That's because that cosine of x is less than 1. And so when you're talking about the integrals of the two, the integral is just a fancy way of defining the area under the curve. So the area under the curve of sine squared of x cosine of x will be less than the area under the curve of sine squared of x. Therefore, when we're looking at these two equations, 1 will be less than 2. And neither one will be 1. Neither of them will be 0, because we saw there was some area under the curve. They weren't equal. 1 is defined. and that one's just wrong. So the answer for this one would be the 1 here would be less than 2. Sounds good? I appreciate you guys stopping by. I will see you guys next time. Go team.